Hello, so like disclaimer, I don't really know how to format this video, uh, but mine's not going to be live action. It's going to be on this whiteboard thingy. This is my presentation on how buoyancy works and why something floats. So basically, when you pour water into a contained area, by the way, this is contained. This isn't just an ocean. Oceans will do the same thing, but I just want this to be contained to make more sense. So basically, water wants to be even. So if you pour it into a thing, it makes it even, right? Now, basically what decides if something floats or not is the density. But it's not all just the density. So if you take this object right here, that is, let's say it's a ball of wood, right? If you take this ball of wood and you put it in, it'll obviously sink. But if you hollow some of it out, wait, what? Are you kidding me, bro? Why is it locked? What's locked? Okay, let's just do it over here. So if you hollow this out with air or make it into a boat shape, look at that amazingly shaped boat. Yeah. So if you take this kind of boat shape, wait, did I? Yep. And then you paste it in, it'll float because it's less dense. Like the boat is less dense than the water because the object has some air in it, right? That's what makes it float. And also if it's just a bouncy ball and it's less dense, it'll float because if it's less dense than the water, then it'll float. If it's more dense than the water, aka more particles are inside the ball, then it'll sink because yeah. Now, one of the reasons this floats is, let's say it hits the water, right? It's in the water. Now, it doesn't just erase all the water underneath it from existence. That wouldn't make any sense. So when you put it in, it actually moves a tiny bit of water away from it, right? It displaces some of the water is the special term. Now the thing is, water, it wants to be even. It wants to be a straight line. So naturally, there will be pressure on each side. So it pushes back on the sides because of pressure. Now the thing is, it doesn't only have pressure on the sides, it has pressure underneath. The underneath pressure is called buoyancy. That is what keeps your thing floating. So yeah, that's what buoyancy is. Now the thing is, if you... Where is it? Can I... Just wait, we gotta rewind time. Please. Okay. Yeah, actually no, this is already on my clipboard. So if you paste this in and use the resize tool because you're cool or something like that, I don't know, and you make it a lot bigger and scale this button, yep, there we go. So if you use the resize tool, sorry, resize tool isn't in reality. It has nothing to do with the resize tool. So if you make the object bigger, when it goes in the water, it'll displace a lot more water, therefore giving it more... Oh, just wait. No, I didn't want to delete it from existence. That's not my goal here. There we go. Okay, so when the object is bigger, it displaces even more water, giving it more pressure on the sides and more buoyancy, which is just pressure, underneath the boat. So that's why... Yeah, sometimes things can be super big, like giant cruise ships, and be made of metal, but yet still not sink, because the more water they displace, the more buoyancy they get. Let's say this is a mystery water that isn't actually water. It's just like hyper water. Now, hyper water, our new magical substance that we just created, is actually a lot denser than water, which means it has a lot more particles. Now, the denser the liquid that you're putting the material into, the more buoyancy it will have, because the more particles are putting pressure against it. It's basically a stronger liquid. Not specifically viscosity, but like, oh crap. Sorry. Oh, well, we have 2 boats now. That's not good. Give me a second. Technical difficulties. Can I kill you? I can't kill this boat, guys. It's taken over. Okay, we just yeeted it off screen. That's how you deal with your problems. Okay, so if you have the same object as before, right? Scale, yes. No, scale. There we go. It'll float way more. It'll float way higher. It'll barely touch the surface. Now it depends how dense it is. The more dense the liquid, the more it'll float. Now if it's like a solid, it won't just rocket into the air. But the thing is, if it's a solid, it won't even go into the liquid. It won't displace anything because it's a solid. So you could say solids have high buoyancy, but I don't think that's legal. Yeah. And I think I already said all the points that I've written down here. Oh, right, yeah, we also have to explain how something sinks. So let's say this is a metal boat. Oh, wow, it's so strong. It's please, give me metal color. Yes, metal color. Okay, where's bucket? There we go. Now we have a metal boat. Look at that. Look at that thick metal boat. It's so strong and it's so dense with lots of particles inside it, which is the whole point. It's just denser, okay? Yeah, so now that we have a metal boat, oh, also we need normal water. Let's just say it sank in the normal water. You see, we need our normal water back, please. Where's bucket fill? There we go. There's crap. No. I don't know why there's holes in our metal boat. Oh yeah, also, the reason, sorry. The reason boats sink when they get holes in them is because pressure is relieved when it gets inside the boat. It makes sense, right? You guys get it, right? I hope so. It's because when there's holes in it, the water gets inside, and then it's straighter, it's more even, and it sinks. Now this could just be dense enough to sink on its own, or it could be light enough to float and it's just got holes to sink. Okay, there's a lot of magenta in here. Magenta cyan. Oh yeah, yellow. That is my presentation on where buoyancy. Yeah, that's not how you spell it. It's actually spelled buoyancy. I think that's how you spell it. Yeah, there you go. That was my presentation on it. Hope you understand why something floats. I gotta stop calling this the buoyancy presentation, but that'll probably be the title of this video. Yeah, bye. Yeah.